Today I will discuss the physics of breakfast, given by Professor Peter Juncker. Breakfast is of course the most important meal of the day, but it also holds many lessons in the world of physics. These simple lessons observed in an everyday activity actually have a huge impact and have applications far outside your bacon and toast. Professor Juncker led off with the coffee ring effect. After leaving your drink sitting out for a while, you may have noticed a ring-like shape forming around the outside of the cup due to evaporation. Why is that? This strange occurrence is called the coffee ring effect. The coffee ring effect is due to the interactions of spherical particles in dissolved liquids that do not disrupt the capillary flow of liquids. While the liquid is drying, the edges of the liquid become pinned. Once these edges are pinned, the cohesion forces that bunch the liquid molecules together work with the adhesion forces attracting the liquid molecules to the surface to produce a capillary flow. This flow pushes the liquid outward to the pinned edges, forming the ring. This is not the case with non-spherical particles. They instead deform the surface and form a solid layer instead of a ring. Next, Professor Juncker discussed the physics of scrambled eggs. How do liquid egg yolks become solid when cooked? Well, everyone knows eggs are full of protein. These proteins are composed of hydrophilic and hydrophobic regions folded on top of each other. Adding heat to these proteins causes them to denature or essentially unfold into a long string of proteins. Once unfolded, these proteins aggregate or come together to solidify into their scrambled shape. Lastly, Professor Juncker discussed the phenomenon of the Cheerio effect. The Cheerio effect is an effect that occurs when floating objects group together on the surface of a liquid. This is based on the interactions of forces and the surface tension of the liquid. Cheerios are less dense than the liquid milk that it sits in, so it forms an upward meniscus, which leans the Cheerios into each other and attracts them together. This distorts the surface of the liquid, which the liquid does not like. Gravity is also still working on each of the individual Cheerios, pulling them downward. Once all the Cheerios come together, their forces balance out and the Cheerios are in equilibrium. This lecture initially interested me because I would eat breakfast food for every meal if I could, but after attending, I had a whole new perspective on the topic. I learned that there is more to breakfast than just getting your energy for the day. It also contains several physics principles that can be seen throughout the world around us. The coffee ring effect can be seen in all dissolved liquids that are composed of spherical particles, but could it also apply to solids or gases and produce the same interactions? The same question could also be asked of the Cheerios effect. Will solid objects sitting on top of the other solid objects of different densities or elasticities come together like the Cheerios? This lecture was another reminder that something seemingly mundane can explain the amazing wonders of the world around us.